two blocks, M1 5 kilograms and M2 3 kilograms are stacked on a frictionless surface, but there is friction between them. The coefficient of static friction between the blocks is 0.6 and the coefficient of kinetic friction is 0.3. If a person applies a horizontal force of 16 newtons to M1, that is the lower block, the blocks move. You do not know if the blocks slip or accelerate together until you check the friction between M1 and M2. What is the magnitude of the friction force between the two blocks? Here, two blocks are stacked one upon the other and they are lying on a frictionless surface. Let us consider the lower block as M1 and the top block as M2. And there is a friction between the blocks, and we have to find out when the force is applied to the lower block, whether the blocks will move together or the second block will slip. That is the question. If at all the second block is slipping, we have to find out the kinetic friction. If the blocks are moving together, we have to find out the static friction. First of all, let us find out the condition. What is the condition for the second block not to slip? For that, the static frictional force must be greater than the contact force. Okay. Now let us find out the contact force. To find out the contact force, first let us find out the acceleration of the blocks. As the person is applying the force on the lower block, and the lower block is lying on a frictionless surface, and both the blocks are moving together, the acceleration is the same for both the blocks. Therefore, the net force is equal to total mass times acceleration. Therefore, acceleration is equal to net force divided by the total mass. Here, the net force is 16 newtons, and then M1 is 5 kilograms and M2 is equal to 3 kilograms. So, acceleration is 7.5 meters per second square. So, if a person, according to the numerical problem, a person is applying 16 newtons force on the lower block, and both the blocks are moving with an acceleration of 7.5 meters per second square. Now let us find out the contact force between the blocks. F contact is equal to M2A. This is based on the Newton's third law. Whatever the force the second block applies on the first block, same amount of force the first block applies on the second block. That means F12 is equal to F21, but in the opposite direction. This is the Newton's third law. Okay. So based on that, we will find out the contact force between the blocks. So F contact is equal to M2A, that is 3 times 7.5, that is 22.5 newtons. Now, according to the condition, we have to find out the maximum static friction. And we know the coefficient of static friction given in the question as 0.6. Therefore, we will find out the maximum static friction. Maximum static friction is equal to 0.6 times 3 times 9.8, that is 17.64 newtons. Obviously, 17.64 newtons is less than 22.5 newtons. The top block will slip. Understood? It will not stick to the lower block and it will slide on the lower block. Therefore, the friction between the blocks is the kinetic friction. Now we have to find out the kinetic friction between the blocks. What is the kinetic friction? Kinetic friction is equal to mu k Fn here for the second block. Okay. So what is Fn? Fn is equal to Fg, because we know sigma Fi is equal to Fn minus Fg is equal to MAy, and then the block is not moving along the y direction. Therefore, y direction acceleration is equal to 0, and Fn is equal to Fg. We know Fg is equal to M2g. Therefore, Fn is equal to M2g. Okay. Therefore, friction is equal to kinetic friction is equal to mu k times M2g, and then plug in the values. We will get the kinetic friction force as 8.82 newtons. Understood? Here, the simple thing is you should know the condition. The condition is static friction force between the blocks must be greater than the contact force. Then the top block will not slide. Okay, it will stick to it and then move. Suppose if the static friction force is less than the contact force, then it will slip. Here, when we calculated the values, we found that the static friction force is less than the contact force. Therefore, the top block will slip from the lower block. Okay. Therefore, we have to find out the kinetic friction between the blocks. Okay. Hope this helps. Thank you. Bye bye.